Hello and welcome to my presentation. I'm Tobias Zwick and I want to talk about how the editor handles edits, how StreetComplete handles edits. So it has three sections, and in the first section I will talk about the data flow, the rough architecture where the edits are sorted in. So that it is easier to follow, let's do this iteratively. And a disclaimer, it's simplified. Look at the displayed URL to see a more detailed overview with the actual class names, etc. Okay, so in the beginning we have this OpenStreetMap API from where we get the data, and on the right side we have the UI. We want to display the quests. So the easiest infrastructure architecture would be to just download the OpenStreetMap data and create the quests out of that. And then the quests are displayed in the UI. And when we do edits, when we answer the questions, then we simply upload the changes, the edits, and that's it. And this is a bit of maybe a website architecture, but the problem is what do we do if there's no connection? If at the precise moment we want to upload the edit, the mobile connection is gone, then we have a problem, then the change is lost. So this is not really a good architecture for a smartphone app. Also, if we close the app or just send it into background, it could be that all has to be downloaded again. That's also not quite nice. So easy fix, we just persist the quests after we created them in a local database, and then whenever the quest database changes, we change the UI, and whenever we created an edit, then we persist it into the database, and whenever the edits database changed, we trigger the upload. So when the upload fails, the edit remains in the database forever. So you can reboot the smartphone, close the app, whatever. When you restart the app, the quests will be there again. This has been the architecture of StreetComplete, the basic architecture of StreetComplete, till version 31, more or less. The problem here is that it's very simple, that's nice, but there's not really any live editing. So maybe you already changed data because you answered certain quests, but it's not reflected, the quests are not updated. For example, the house numbers for buildings are only asked for buildings that, for certain building types, like apartment buildings or detached houses, but not for garages. So before you answer the building type quest, the house number quest will not appear. And after you answer this, then with this architecture, you still don't get the quest, because you first need to upload the change and then download the change, and then you see the quest. So that's not so nice. So what can we do about that? We do it like probably most general purpose editors do it. We download the map data, and then we persist that map data and don't generate the quests out of that immediately and throw away the map data, but have a local copy of the downloaded map data. And whenever that map data is updated, then the quests are updated as well. The rest is the same. So then the edits are not uploaded directly, but the edits also apply to the map data. And thus the map data changes, and thus it is triggered that the quests are updated. So are updated. This way we have this loop that when you answered, for example, for a building that it is indeed a detached house, then the new quest will be unlocked. And finally, from the map data, the things we changed are marked somehow, and those changed things are uploaded. For at least for StreetComplete, this has a few problems though. First of all, it's now really difficult to undo the edits, or at least not that easy anymore. Before, we could just remove an edit, and the edit was removed. I mean, remove it from the database. But now the edits are applied to the map data, so we would need to reverse the edit somehow. And that needs code. We need to code how can we undo an edit. For simply tag changes, this is trivial, but imagine reverting or reversing the splitting of a way. That's quite complex, and it's too bad that this is lost here. Also, when we upload changes, StreetComplete usually solves conflicts automatically, or tries to do it. If it fails, then the own edit is dropped. Now, if we upload all the edits we added to map data in one chunk, and the OpenStreetMap API says, well, there's a conflict somewhere, then it's kind of difficult to find out, okay, where was the conflict, and to solve it automatically, because the edits are chunked together in one big change set and not atomic edits anymore. And finally, also on download, when we scroll the map, StreetComplete updates, downloads the new areas. And then we have the problem, well, the download could overwrite our local map data. That would be bad, because then we lost our edits, or has to merge them somehow. And then, of course, there can be conflicts as well. So we have several points at which there could be conflicts, and it's not trivial to solve them. Maybe we can do it a little better or a little easier, like this. So it's basically the same, but the map data object is not changed from within the app. It's only ever updated from the OpenStreetMap API, either on download or update after an upload. The local map data object is updated every time the original map data updates or the edits update. So it's more or less a cache. It's the original map data and the edits applied on top of that. Yeah, and so this is how StreetComplete does it now. Let's put it into the corner now and review what is good about that architecture. So first of all, it becomes possible now to work with map data offline with StreetComplete. This is, well, more basically it's a basic requirement for any general purpose editor, but StreetComplete is not a general purpose editor, and it was working before without this capability. But it's good to have it now, because more things are possible with that. And on top of that, we have still this undo, easy undo. And third, the conflict handling is really easy, because we still have these edits grouped as, or we have these single edits still. So if there's a conflict for one edit, then we can drop that one edit, but the others can still be uploaded. All right, so, but what is an edit and how are they applied? So yeah, an edit is an atomic action from the user perspective, not from the technical perspective. This is a big difference. I will explain this on the next slide, but now, first, what is an edit? It contains the original map element that it refers to for conflict checking, to see if something big happens so that the edit should not be applied. Then also the type of edit. There are different types of edits, for example, splitting away, deleting a point of interest, or changing some tags. That's the most common one, and also the most easy one. And then finally, of course, the diff, the necessary info and the minimal info that describes what is changed. So as promised, the example for the split way, what is an atomic action? So we split the where here and there, and that's the user action from the user point of view. Let's say we have this road and there's a parking lane on the left side. This is the geometry, and now let's look at what needs to be done from the technical perspective. First, we need to add the vertices at which we want to split the way, and then we modify the original way to only consist of the longest segment. That's the best practice anyway. And for the rest of the way, we create actually new ways and put all the tags, or at least the applicable ones. Maybe we shouldn't put step count, for example, in there, into these new ways. And then, finally, this is the most complex part, we need to update all the relations that refer to the way. And also there's extra logic for from-to relations. What this should show is that an action from user perspective is very different from an action from the SotM API perspective or the technical perspective. What it also shows is that the action needs to know some kind of repository of map data. In this case, the split way would need to know the edit action would need to know what are the relations that refer to this way, and also all the nodes that are referenced by this way. Alright, so an example edit queue would maybe look like this. We change a tag for a node, or we split away at a certain position, and maybe after that we add another tag, or add another tag for one of the newly created ways. And of course, one action can also be that several tags are changed. In this case, the user was asked what kind of building is this, and the answer was it's a storage tank, so several tags need to be changed. So how does an edit create changes? Maybe you recall this other diagram a few slides back. The edit is applied to both the local map data, but is also applied when uploading the change. And since we don't want to have a duplicate implementation, there's just an interface, a map data repository, and both the local map data and the uploader for the OpenStreetMap API would implement that interface. And this map data repository supplies all the information the edit needs to do the edit. In this case, or for the split way, I already mentioned the edit needs to know which relations refer to the way, and also all the nodes of the way. And of course also the way itself. So first, the edit will get the current version of the map data element it wants to edit and compare it with the original version of the map data element to see if it can and should be applied. So it cannot be applied, for example, if the change was to set the building type to apartments, but in the meantime the building type already has been changed to something else. Then it's a clear conflict and it cannot be solved automatically. And it should not be applied if, for example, the geometry of the node changed, or the way changed significantly. For example, if the node was moved more than 20 meters or something, maybe it's now a completely different thing. Sometimes mappers do something like this. So they reuse nodes and other map data elements for other things. Or for example, if a way has been split, then it should also not be applied. Yeah, and finally, after deciding if it should reject or apply the edit, the only thing the edit does is to return the updated elements. And what will be done with this, with these updated elements is up to the uploader or the local map data. So the local map data would just get those elements and put it into its local store, and the uploader would get those elements to upload them to the OpenStreetMap API. Alright, section 3. So how can we undo and how can we revert? Maybe you know that StreetComplete can also undo edits that have already been uploaded since forever. Alright, so first of all, uploaded edits are not cleared from the database, but they stay in the queue. But they are marked as uploaded, so that they are available for undo even after upload in the UI, so you see what you've done. So how to undo an edit? Let's say the user answered that he can't find the bench he was asked to locate, so the bench will be deleted. But seconds later, or minutes later, or hours later, he discovered that the bench is still there. Maybe only at a slightly different position, or he wasn't looking properly. So he wants to undo this edit. And to undo this edit, there's just one information that needs to be acquired. Was it already uploaded? If not, then we can simply delete the edit. When the edit is deleted, then the local map data is notified of that change, and thus updates its data model, and thus the quests are also updated, and the quest that asked for the bench, if it's still there, will be notified, will be recreated, I mean. And if it has already been uploaded, then we also delete the edit, but we add another edit to the queue of to be uploaded edits, marked as a revert, because revert edits should not appear in the UI, because you shouldn't be able to undo reverts. So here you see how it looks like in the UI. The edit history, you can undo any edit in any order. And again, for a more detailed overview, see this URL. And now I'm happy to take your questions.